welcome back. I will take few pieces of code and show you how to analyze them, how to find out the time complexity for them. This is a simple loop. I am not writing a complete algorithm. I have just written a piece of code in which one statement is there. Now we are already familiar with this one. We know that this will execute for n plus 1 time and this will execute for n time. We don't want this time because anyway when we are writing order of, we are writing a degree. So this will not affect the degree at all, so it will be same only. So just we need to know the statement, how many times it's executing. So that's it. So this is order of n. You can avoid this one, skip this one. Next, if suppose this loop is starting from n and the condition is greater than 1 or 0 and this is getting subtracted, so this loop is decrementing, then also this statement will execute for n times and it's order of n. Whether you go from 1 to 10 steps, or come from 10 to 1, then also 10 steps. So you go from 1 to 10 or 10 to 1, same number of steps. So that's how n to 0 it is. So this is also order of n. If this is starting from 1 and condition is less than n and I is being incremented by 2, so this statement will not repeat for n times but half of the n times, n by 2. If it is n by 2 also, if I say function is n by 2, what is the degree of polynomial? N only. So it's order of n again. So in this case also it's order of n. Even if it is incrementing by 20, then this is 20. Degree of a polynomial is n, so this is also order of n. So n by anything, this whatever the number of times it is incrementing, the time will be same on. Next, we are already familiar with this one. These are two loops, nested loop, one inside another, and this we know this will execute for n times. So this is also n times and this is also n times. Actually it is n plus 1. But what about this one? Again this will repeat for n plus 1 times and this will repeat for n time. And this is order of n square. The next is again nested for loop. This looks similar to the previous one but not. See, I takes value 0, I less than n, but j takes value j less than I. So here is the difference. So let us analyze this by tracing this one and find out how much time it is taking. So for this, I will take I value and j value and trace them. Let us start. Initially I is 0. When I is 0, j starts from 0 and 0 less than 0. No, it will not execute for any number of times. So here I have to find out how many times this statement is executed. So number of times. So it will not execute at all, so 0 times. Then this loop ends. Again, I plus plus. I becomes 1. I is less than n, suppose. It's entered inside. Then again this loop, 0. 0 is less than I. Yes, for 0 it will execute. Then j plus plus. J is 1. 1 is not less than I. So for 1 it will not execute. So how many times it has executed? 1 time. Then goes up again. I plus plus. I becomes 2. Then j will execute for 0, 1 and when it becomes 2 it will stop. So this will repeat for 2 times. And when I is a 3, j will take 0, 1, 2 and 3. So this will repeat for 3 times. And this process continues. See, when I was 0, it was never executed. When I was 1, it was executed for 1 time. This is statement. I was 2, it was executed for 2 times, 3 times, so on. So on, up to what? N. So total, when it is n, right, how many times this will execute? N times. When I was 3, so 3 times. So if it is reaching till n, actually it is less than n, but let us say n, it is reaching till n, so it will execute for 10 times. So total how many times it is executed? This one. Right? So I'm assuming that it is going till n, though it is not till n, it is less than n. How much that is? 1 plus 2 plus 3 plus goes on to n. This is nothing but n into n plus 1 by 2. What is the degree of this one? F of n is n square plus 1 by 2. Degree is square. So order of n square. So the time complexity is order of n square. Though this is not similar to the previous one, but if you analyze, the answer is coming to n square only. The degree of a polynomial is n square only. Next code is, here p is initialized to 0 and there is a loop. This is not going to execute for n times. See this p is less than equal to n. It's not I less than equal to n. So the condition is different. Then what is p? P is initially 0 and every time I is added to p. So now we don't know how many times it's going to execute. Let us analyze. I will take I value and p value. Initially this is 0 and this is 1. So what happens first time? This 1 is added and it becomes 1. The next time it will be 2. So it will be 1 plus 2. So it will be 3. The next time I will be 3 and this will be 1 plus 2 plus 3. Then I will be 4. It will be 1 plus 2 plus 3 plus 4. Goes on. How many times it's going to execute? It's going to execute for k times. So what this will be? 1 plus 2 plus 3 plus 4 plus goes on to k time. Why I wrote k here? It's not reaching, it is not repeating for n times. Definitely it is repeating for some number of times that we don't know. We are sure that it will not execute for n times. Then how many times? Because the condition is different. So I said let it be k and let us find out that k. So if it is repeating for k times, then what is the condition? We assume that p has become greater than n. So when p became greater than n, it is stopping. We assume this. As long as p is less than equal to n, it is repeating. So when p becomes greater than n, it is stopping. Right? Since p is what? See p. See? It is k into k plus 1 by 2. P is k into k plus 1 by 2. So what is the condition? K into k plus 1 by 2 is greater than n. So when it will stop? When k into k plus 1 by 2 has become greater than n, it will stop. So what is k? Roughly we assume it as k square. So what is k? K is root n. K is root n. So this loop will execute for order of root n times. Let me show you quickly. I assign 1. P is less than equal to n, I plus plus. This is not I less than equal to n. So we don't know how many times it is repeating. I is here, P is here. So I values are incrementing and every time I is added to P. So we don't know how many times. So let us say k times. And this will be 1 plus 2 plus 2 to k. Right? So that k is p is k into k plus 1 by 2 now. So we know that this will repeat as long as p is less than equal to n. So it will stop when p becomes greater than n. So when p becomes greater than n, it will stop. So k into k plus 1 by 2 becomes greater than n, it will stop. So this is k square and k is root n. In the next video you will find more examples, right? So different type of codes I will show you and I'll show you how to analyze them. So this is how by tracing you can analyze them. So in the other video, next video also you can find few more algorithms with tracing.